All right, folks, we are back with another session. We are continuing going over chapter 7, which is configuring and verifying interfaces, right, on a switch. Okay. And yesterday we had Lab Fun Day, and what we were doing, right, is we were going over, a couple of these objectives that we went over the other day. Okay. Emulating a switch through our virtual software, EVNG, right, using a Cisco switch, and we went through how to configure, speed, duplex, how to configure a description, all under an interface, right? We went over how to configure multiple interfaces at the same time, right? And we also went over how to verify, right, those changes, right? Because of course, within everything that we do in network engineering, even though we trust ourselves and we trust others that things are being done, we have to make sure and verify that things are done, aka that coined the term trust but verify. Okay. Um, we went over, of course, seeing the differences um, of using the different commands um, to verify the changes that you made to interfaces, right? We went over shorthand versus longhand doing commands, right? And of course, as always, as a big reminder, I'm going to push you guys to always do longhand just for now, until you guys get a good handle of being in the CLI, and you guys can start, using your wizardry to shorthanding all you want, right? We went over, of course, administratively controlling interface state with the shutdown command, right? Shut down a few interfaces. Show you guys how that looks like in the different commands that show interface, interface name, slot number, status command, and of course, just the show interface slot name, slot number command, right? So we saw both and we got good information, right? And I'm sure you guys can see a pattern here, right? A lot of these show commands, right? They're going to give us the same results, but it has different information within its command, right? It gives us some of the same, but some different, right? We saw how to basically undo any configuration that was done on the switch using the no command, right? We reversed any changes that we made, right? And we verified the reversal of those commands, right, that we removed with the no command in our running configuration, okay? And so after doing that, right, after we verified getting that done, right, within that lab, I couldn't help it, right? I had to keep bringing up what auto negotiation was, right? Because that was a big hiccup for our lab to continue, okay? And, you know, by default, right, you know, switch physical interfaces, and I believe router physical interfaces, right, by default, right, out of the box, lab environment, and sometimes with the production environment, based on the make and model of switch, they come pre-configured to auto negotiate, right? Auto negotiate what? What does that mean, right? And if we break down the term auto, right? Auto means without manual use to go ahead and get something done, right? So there's no manual things being done to help negotiate, right? And let's go into the second part of that, right? Negotiation, right? What are we negotiating, right? Well, there's a couple of things, right, that we need, right, in order to send data to and from a source and a destination, right? Um, and if we use the OSI model, right? If we use the OSI model, right, and you know, if we're going down, right, we have we have our request from our application, right? We're using the application protocol. We're enveloping it in, right? We're enveloping it and getting it ready to send on the wire, right? Before it can send anything on the wire, right? At layer 1 and layer 2, right? We need to confirm that both, that host, right? Probably your PC, and maybe the switch, right? Can agree to a few things, right? It needs to agree on one, right? That it can receive data, you know, and send data at the same time, right? And what that means is running in a certain duplex mode, right? And it also needs to agree on, how fast that link is, right? Maybe, Ryan's PC has a speed, right? It's NIC, right? It's network interface card, right? Maybe it has the speed of 1 gigabit, right? And below, right? So it's probably a 10, 100, or 1 gig, right? Maybe the switch is a 10 and 100. Okay. So when auto negotiation, right, is configured, right, on both sides, right, the great thing about it is that, again, Ryan doesn't have to do any manual configuration, right? All he has to do is plug things in, and what'll happen is these two hosts will communicate and say, hey, this is the highest duplex, right, and speed that I can, provide to you, right? And the other host will say, hey, here's the highest duplex and speed I can provide to you as well. All right, cool. Well, since me being the switch can only provide a speed up to 100, and you can provide, right, Ryan's PC can provide a speed up to 1 gig, right, 1,000 megabits per second, right? But Ryan's PC can go ahead and support lower speed, like 110 megs. They're going to auto negotiate, right, to a speed that they both support, which will be 100, right? They both support 10 megabits per second as well, right? But with auto negotiation, it's going to go to the highest speed and duplex that they both can agree on. Okay, so auto negotiation. All right. So let's go ahead and talk about how that looks like, right? In under working conditions. Okay. And if we take a look at this, right, it's self-explanatory, right? Working conditions, we see this picture, right? Maybe just like we were speaking about in my example, right? The switch, right? You see 10/100/1000, right? And what that means is megabits per second, okay, in reference to speed. What that means is all of the speeds that physical port can handle, right? Whether it be a switch, whether it be a host, maybe a PC or VMware box, whatever. It's telling you how much it can support, right? We have David's PC, right? We'll call that PC number one. That's right here, right? I typically get old PCs because I'm an old man, right? So my PC is run at 10 megabits per second speed, right? And it can run, right, at full or half duplex, right? So I plug it into my switch. It's going to auto negotiate based on my last example and the definition. It's going to auto negotiate to 10 because that's the highest speed my PC can support. And it's going to negotiate to the highest duplex, right, that they both can support, which is full, right? And of course, and so on and so on and so on. So this is how it looks, right, in a working environment, right? Everything is perfect, right? There's no issues, right? The ports can auto negotiate. We're all good, okay? And so again, all of this, right? Auto negotiation, to get a little bit technical, right? They all fall under, right? The Ethernet standard from IEEE, right? All of this, and there's different standards. Of course, we went through on earlier chapters, right? Regarding 10 base T, 100 base T, 1,000 base T, right? And these are just the Ethernet cables, right? Ethernet cables that pass, that connect via physical media, that pass these bits along the wire, right? And what are these bits, right? These bits is the broken down, right? The enveloped, right? Packet, right? The enveloped packet that all encompass these requests that come from our computer. Okay. So once we envelop it, it gets onto the wire, which is layer one, the physical. It needs to get out, right? But we need to make sure the speed and duplex, right, is negotiated first before any communication happens between a source and a destination, right? The great thing, right, about auto negotiation, right, and I'm sure you guys can already probably muster it within your head just using knowledge, just using logic, right, is the IEEE auto negotiation protocol, right? It helps so much, right, to just operate a local area network, right? Because who has times to go to every host and to the switch to plug in, right? To plug in, what the speed is on one side and what the speed is on another, what the duplex is on one side and what the duplex is on another, right? This helps so much in terms of having multiple switch ports, probably 24 ports, 48 ports, right? That connect to many end users, right? Or downstream devices, right? Makes things a whole lot easier, right? So auto negotiation, right? Being under the IEEE standard, right? 802.3, right? It helps out with operations for sure, right? Now we're looking in this, right? We're looking at this in a perfect environment, right? And how it works, right? But what does it look like in a maybe in a non-working environment, right? Maybe it's broken, right? I wanted to stop here, right, and take a screenshot of this. And by the way, right, these screenshots are from the Cisco 200-301 official certification study guide, right, by Cisco Press. So all credits due to them. Want to take a step here and remind you guys, right? On negotiation, right? Everything I just said based on theory, right? And it just confirmed all of my blabbering I just did in the last two slides. That auto negotiation relies on the fact that the IEEE uses the same wiring pinouts for 10 base T, for 100 base T, and 1,000 base T, right? 10, 100, 1,000, I'm sure you guys can understand that means 10 meg, 100 meg, 1,000 meg, right? That's the highest speed, right, that it references based on these names, right? And of course, they could support lower speeds, but of course, the highest speed is going to relate to the name. So 100 base T can support, of course, 110. 1,000 base T can support 10, 100, and 1,000 megabits per second, aka 1 gig, right? And what it does is it simply adds those pinouts, right? Adding 2 more pairs. All right, let's keep going, right? So, how does it look, right? Whenever it's just, I'll take my word back. Not so much, not in a working environment, but how does it look when only one side, right, can perform auto negotiation, right? What does that look like, right? And so, right, when we look at the last picture, right, everything looked perfect, right? Only negotiation happened on both sides, right? But what will happen, right? What will happen? So if we see to the right, right, we see that the manual settings, right, are on all the PCs. Okay, the speed is set, duplex is set, right? And I want you guys to look at PC1, right? It's, manual settings are set, right, on one side, and of course the switch is disabled on the other. Okay, and so, one second, guys. Okay, sorry about that, guys. I think it was a spam call, but right. So let's look at this, right? So PC1, right? So what is happening here, right? The switch, it receives no auto negotiation messages, right? Because that's what it's looking for first, right? So, so it's thinking, I'm not getting any auto negotiation messages, even though I'm connected, right? But, right, within these Ethernet cables, electrical signals are being sent, right? So it knows, right, and it learns, I'm getting data at 100 megabits per second. What the switch is going to do in its software, it's going to say, 100 megabits per second, right? I'm going to default that to half duplex. Let's look at PC2. So PC2, right? The switch is doing the same thing that I just talked about in PC1, right? Is going to hear, right? Even though it doesn't get any auto negotiation messages, it's going to hear and see that it's sending data at 1,000 megabits per second, aka 1 gig. It's going to say, based on my software, if I see data being sent at 1,000 megabits per second, I'm gonna, aka, tell myself to configure this to 1,000 megabits per second in full duplex. Okay, let's look at PC3, right? So, right, PC3, right? Let's say Ryan is helping set up the whole office, and I bring my PC from home, right? And Ryan statically sets it, right? And so, you know, I go ahead and go behind Ryan, right? And set speed statically, right, to 10 megabits per second, right? And I set it to the worst duplex, right, which is being half, right? What will happen is the switch that Ryan set up, right? Ryan didn't make any changes on his side. It will detect it, right? IEEE auto negotiation within the switch will, in a sense, auto negotiate within itself, right? Because there's no auto negotiation messages coming from my PC. It'll auto negotiate with itself, seeing its software, and say, I'm seeing speeds, I'm seeing data being sent to me at 10 megabits per second. I need to go ahead and default that to half duplex, right? And so this is how it looks like when only one node uses, right, auto negotiation. Now, let's take a step back because we're getting to the fun part, right? And this is my favorite part. And this is where things break, right? Let's take a look back to PC1. We're going to be on this slide for a while, right? PC1 shows something very common, right? That happens, man, that's, oof, I have too many horror stories. You see the duplex, right? The duplex is full on one side and half on one side, right? And so with PC1 using full, right? Fast Ethernet 0/1 using half, what we have here is a duplex mismatch, right? Even though they're the same speeds, right? So they can send data to each other, right? PC1 is running full, right? And fast Ethernet 0/1 is using half. What's going to happen is PC1, and we'll talk about this theory that I'm going to mention in a second. PC1 is going to say, I'm not going to attempt, right, to send data, right, by using carrier sense multiple access with collision detection logic, right? Because that's a logic within layer one, right? This is how we got to, switches existed and et cetera, et cetera. We'll go over that history lesson probably in the future, right? This is how full duplex works, right? And how it's able to send frames at any time. With the switch port being half duplex, right? And it also uses carrier sense multiple access with collision detection. What's going to happen, right, is the switch port is going to think, right? It's going to think because it's seeing that data go back and forth, and data being transmitted. It's going to think that collisions are happening on the link because it's running at half. Okay? It thinks that collisions are happening because it's running at half duplex, meaning it would have to wait until data is not being sent anymore to send data. With that being said, it's going to go ahead and the switch port is going to say, hey, stop transmitting data, back off, right? Relax, resend those frames, and it's going to keep doing that and doing that and doing that, right? Case in point, a duplex mismatch, right? And so the switch is going to notice that and say, hey, I'm just going to shut down the port, or I'm just going to keep running in a circle using the CPU, et cetera, et cetera, et cetera, right? And so this is why, right? A lot of us, right? If manual intervention is not needed, right? We want to go ahead and default to just letting the switch and the host do its thing, right? And just auto negotiate. Okay. I know that was kind of lengthy, and of course I got long-winded, but I wanted to make sure you guys understood, right? Or at least got a piece. I know I didn't get too technical, but at least you guys understood what that means, right? And so, and I know we're going over time, but I wanted to make sure you guys understand this stuff, right? Let's read this entire thing because it's very important for layer one, and of course dealing with switches. Of course, this is a huge fundamental, right? So let's go down the list, right? So the first note, right? Configuring both the speed and the duplex on a Cisco Catalyst switch interface disables auto negotiation. You guys saw our lab yesterday. We had issues, right? When I tried to configure the speed in Duplex, of course, it didn't let me because, of course, I had to disable auto negotiation. To make this point very clear, the newer switches, right, that the CCNA reference, right, in the newer software, you do not have to actually manually disable auto negotiation. As soon as you set the speed and the duplex, it will disable auto negotiation, right? My switch and our switch, I'll call it, in our lab is running on old code. Okay. So just wanted to make that clear, right? And so going on next, right? One thing we have to remember is that all of this is a standard. This isn't just make believe, right? The IEEE, right? The standard that creates standards for how things work, how things operate within technology, right? The IEEE auto negotiation defines some rules, right? Defaults that nodes should use as defaults when auto negotiation fails. That is, when a node tries to use auto negotiation, but hears nothing from the device, right? Right? So what are those rules, right? And this is referencing PC1, right? So guys, just remember what we talked about and remember PC1 connected to the switch, right? And we're all working in Ryan's environment, right? So the default, right? Again, these are the rules. If one node tries to use auto negotiation, but here's nothing from the device, right? Here's what happens, right? And the device being the switch, right? Speed, use your slowest supported speed, right? Often 10 megabits per second, right? Duplex, if your speed is 10 or 100 megabits per second, use half duplex. Otherwise, use full duplex. Okay? So, PC1, my PC, right? I can either run at 10 megabits per second or 100 megabits per second. Okay? And so, ooh, okay. Sorry, something flew mine, right? It's saying use your slowest supported speed, often 10 megabits per second, right? And so we're going to say, right, since it was statically set on one side to 100, and the switch is the one that's waiting for auto negotiation, right? It's waiting to hear that, right? These ports are 10, 100, and 1,000 megabits per second. It defaulted to 100, right? But if we look at the other rule, right? If the speed is 10 or 100, use half duplex, otherwise use full. What did it do? It heard the electrical signals and it see that data was being sent to it at 100 megabits per second, right? So it defaulted to 100, right? Because of course it supported that. That's the slowest speed supported, right? If it didn't support 100 or 1,000, it would have of course defaulted to 10, right? So it didn't support 1,000, so it went down to 100, right? But the duplex, it went to half, right? Because look at the rule, right? If your speed equals 10 or 100, use half duplex. Otherwise, use full. Okay? So just remember that, right? Let's keep going. Cisco switches can make a better choice than the base IEEE speed default because Cisco switches can actually sense the speed used by other nodes, even without IEEE negotiation. As a result, Cisco switches uses this slightly different logic, right, to choose the speed when auto negotiation fails. Okay, this is the Cisco switch, right? We're going to reverse this, right? This is the Cisco switch that Ryan configured and my PC is plugged into it. So here's Cisco logic, right? Speed. Sense the speed without using auto negotiation, but if that fails, use the IEEE default. Slow supported speed, often 10 megabits per second. So Ryan's Cisco switch, right? I plugged my PC in, PC1, right? I went ahead and I set it to 100 megabits per second and set it to full duplex, right? And so Ryan's switch said, I can sense the speed, I can hear the electrical signals. I'm gonna go ahead and set the speed to 100, okay? Right? So it followed the Cisco logic, right? Your switch did right? Let's look at duplex, right? Using the IEEE defaults, right? If the speed equals to 10 or 100, use half duplex. Otherwise, use full, right? So exactly the same, right? Exactly the same. The only thing that changes, right, as far as in the logic is the speed, okay? But the duplex is the same, right? If it hears 10 or 100 megabits per second, Ryan Switch is going to say, hey, I'm going to go ahead and set the duplex to half duplex, okay? So let's keep going. Hopefully that makes sense. You guys have any questions? Okay. All right. So let's keep going. Let's keep rolling, right? So, couple of things, right? And this will close out today's session, right? Because I know I talked about this yesterday, right? So on the left, we have a switch, right? And on the right, we have a hub, right? This was the hub is a grandfather, right? Grandfather device for the switch, right? We had a hub, then we had the bridge, then the bridge created the switch, right? It evolved to the switch, right? And so hubs, right, since they run at half duplex, back in the day, they only ran at the highest speed that they could run is 10 megabits per second, right? And so the thing is, right, with hubs, right, they impact how auto negotiation works, right? The thing is, hubs don't even participate in sending auto negotiation messages, right? They don't even forward these messages, right? So if it receives messages from the switch and say, hey, I'm going to go ahead and send you some auto negotiation messages, right? It's not even going to send it, forward it. It's not even going to do it to its own host that's connected downstream, right? What's going to happen, right, is devices that are connected to the hub, right, it's going to use the IEEE rules for choosing the default settings, right, which often is going to default to 10 megabits per second and half duplex, since the hub is a half duplex device and it's going to run at 10 megabits per second, right? And so what happens, right? What happens when that hub is plugged into the switch, right? Based on the rules that we just went over, right? The Cisco device, right? Ryan's switch one, is going to see it, right? And not get any auto negotiation messages because the hub doesn't send it. It's going to detect data being sent via electrical signals, is going to say, hey, I detect speeds of 10 megabits per second. So I'm going to set my speed to 10 megabits per second. Based on the IEEE standards, IEEE default set in my device, my logic is I'm going to set my link duplex to half, right? All right. And again, this is because of the CSMA/CD, right? What is CSMA/CD, right? It is the collision. Give me 1 second. Let me make sure I don't say it wrong. It is the carrier sense multiple access with collision detecting logic, right? Meaning it is going to wait and see if it hears, right, hear anything on the wire, right? And make sure, hey, it is clear to go. It is okay to send data, right? And it will begin to send data. But if it senses, right, keyword senses, if it senses anything on the wire, right, the wire being the carrier, it is going to sense it and say, hey, I want to avoid this collision. So I'm not going to send data, right? So imagine how people that are connected, right? These hosts, PC3, PC4, that are connected to the hub, how slow their computer's going. They're probably running AOL or something because it's really that damn slow. Okay. So with that being said, right? With that being said, that is how auto negotiation works. The different flavors, right? The different scenarios, if it's in a perfect environment, if both sides are using auto negotiation, or if just one side uses auto negotiation, right? And of course, there's standards with just the IEEE and devices using those IEEE standards, right? Cisco in the book doesn't know how any of these other devices work, but Cisco does teach you, right? And go over how it reacts, right, to auto negotiation in those two scenarios of if both sides are using auto negotiation, or if if the other device is not, right? So that is auto negotiation. If you have any questions, reach out. I try to answer them as best as possible, right? And of course, our next session will be Lab Fun Day. So we will be going over auto negotiation. We'll be seeing how that looks. And I might have a little treat for you so we can actually see how how those bits are being set and how that negotiation is happening on the wire. Okay. All right, guys. We have a great day, and I will see you next week.